So, hello everyone. Today we are going to discuss one problem from Bstat Bmath 2016, the first problem, which says that suppose in a sports tournament where there are n players and each pair plays one game. Okay, so if you take any pair, or basically if you take two players, they will play only one game, and there is always a winner and a loser. Okay, so there is no draw, and show that the players can be arranged in an order that is p1 p2 dot 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 pn. Okay, so it's not like p1 is the first player, it's fixed. Okay, so it's telling you to arrange the players in such an order, okay, such that pi will beat pi plus 1. Okay, and this will happen for all I from 1 to n minus 1. So the problem will look a little unfamiliar first. So let's try to understand the problem. So let's get a better understanding of the problem. So what is happening is that suppose you have player number 1, player number 2, 3 dot 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 till n. Okay, you have n players. Now or let's name them as A1, A2, A3, AN. These are the n players. Okay, they came to play, and then you take any two of them, they will play a game. Okay, and that will happen for every such pair. So that means you will have n choose 2 such matches, right? And when you are having n choose 2 matches, so always in every match there is a winner and there is a loser. Okay. Now out of these n choose 2 games, you now see that can I have players arranged in a line such that the player at the beginning will defeat the next player, and the next player will have defeated the next player. So suppose I suppose I can have one player which has defeated another player. Okay, so I name that player as P1. Now P1 can be any one of the player from here. Now I see that P1 has defeated some other player. Okay, so that is, suppose I name it as P2. Now again P2 will come from here. So P1 has defeated P2. Now it can't be like P2 has defeated P1. So like all the games are over now. Now you just you are checking that can I arrange all the players in a line such that now next I can have a player P3 where P2 has defeated P3. And, so there should not be any relation between P1 and P3. P3 could have defeated P1. P1 could have defeated P3. Doesn't matter. It all says that Pi has beaten Pi plus 1. Okay. Again, like this, can I have another player P4 where P3 has defeated P4. Okay. And so on till Pn. So the question is that can I arrange the players in this manner such that P1 has defeated P2, P2 has defeated P3, P3 has defeated P4 till Pn minus 1 has defeated Pn. Okay. Now you can think of simple cases like suppose if there is a player whom everyone has defeated, then you can easily put that player at the end, right? And suppose if there is a player who has won all the games he or she had played, then I can put that player at the beginning, right? So, but what about the middle players? And there are n players, right? So how do you tackle the whole problem? So now how do you attack this problem? So your hint would be to think in terms of mathematical induction. Though this this problem looks like a combinatorial problem, but no, it's not, and we should attack this problem. So your hint would be to use mathematical induction. Okay, so think about it and then let's discuss the solution. So you can pause this video and think. Okay. Now let's come to the solution. So what happens is that we have those n players, right? And now if you want to apply mathematical induction, so the first thing about mathematical induction I would like to say is that it's not always like when you're applying mathematical induction, it's like I prove it for n equals to 1 and then for some n equals to k, and then I go for proving n equals to k plus 1. So that's not true. Like some statements might be like valid for n greater than equals to 2 or n greater than equals to 5. Okay. So here as you can see, this statement is valid for n greater than equals to 2. Because if you at least don't have two players, then how will they play the game? One player cannot play a game, right? So n should be greater than equals to 2 here. So our base case is n equals to 2. Now this is simple. It's a very trivial, like you have two players, A1 and A2. Now they play only one game because it's 2 choose 2, that is 1. So if there is only one game, and you know that either A1 will win or A2 will win. So if A1 wins, so if A1 wins, so that means A2 lost. Okay, so that means I'll take P1 as A1 and P2 as A2, right? Because P1 has beaten P2, because A1 has beaten A2. Okay, and if the other thing happens, that is A2 beats A1, then I'll just take P1 to be A2 and P2 to be A1, as simple as that. Okay, so there can be two cases because they are playing a game, so there can be two cases, and in either case I can arrange them. Done for n equals to 2. Now we will form our hypothesis. Suppose the hypothesis suppose the statement is true for n players. So the statement is true for n players. This is our mathematical induction hypothesis. Okay, and now next what are we going to do is we are going to prove it for n plus 1. Sorry. N plus 1 players. So for n plus 1 players, what happens is that if I take any n players out of it, okay, so suppose I have A1, A2, A3, A n plus 1. Okay, so let's write A n also. So I have A1, A2, A3, A n plus 1. And now what happens is that I'll take, suppose I can take any n players. Okay, so let's, for example, or let's take the players A1, A2 till An. Okay, and now my hypothesis says that This statement is true for these n players, right? So that means I can arrange them in such a manner such that this pi will beat pi plus 1. So let's do it then. Now here I have p1, p2. So only I'm concentrating on these n players, not, I just keep it aside. Okay, the a n plus 1 I just keep it aside, and then what I do is I can make them stand in a line p1, p2, p3 dot 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 till pn. Okay, these n players, by induction hypothesis I am arranging them into a straight line such that p1 has beaten p2, p2 has beaten p3. Okay, so it's not a transitive relation like p1 has beaten p2, p2 has beaten p3, so that doesn't mean p1 has beaten p3. It's not a transitive relation, and so on till pn minus 1 has beaten pn. Fine. Now I have to bring this player and make it sit somewhere here, right? So what I can do is, like, suppose this is anything like okay, let's for now keep it as a n plus 1. Now suppose a n plus 1, that n plus 1th player has beaten every one of them. Then what I need to do, like, that means it has beaten p1 as well, right? Whoever p1 is, it has beaten p1 also. So that means I can bring a n plus 1 and put it here, because then the condition is being satisfied. That is, a n plus 1 has beaten p1 and p1 has beaten p2 and so on. Okay. Now this was a trivial case. Now the other trivial case is like this n plus 1th player has lost to all the other players. So that means I can just then put a n plus 1 at the very end, because if this n plus 1th player lost to every other player, so that means pn, whoever pn is out of them, that player also has defeated a n plus 1, and so I can just put a n plus 1 at the very end. Okay. Now if these two cases are like they were trivial, now what about the non-trivial cases, like this player has defeated some players here and also got lost to some players, okay, also got beaten by some players, okay. So then what do we need to do? So then what, okay, so this is interesting. Then what we'll do is we'll go, whoever p1 is, will ask that has the nth player defeated you, okay. So then if this p1 player says that yes, a n plus 1 has defeated me, then I'll just simply put a n plus 1 here at the very front. Doesn't matter, it's a n plus 1 has defeated p1, that only that matters. If a n plus 1 has defeated p2 or not, p3 or not, doesn't matter. A n plus 1 has defeated p1, I just put it here, okay. Now suppose p1 says that no, I have defeated the n plus 1th player, okay. So then what I'll do is I'll go and ask p2 that have you defeated a n plus 1, okay. Then if the answer is that yes, sorry, I missed one case, that is a n plus 1, this n plus 1th player, if it has defeated p1, I just bring it and I'll just let it sit at the very beginning. Now again, this I'll check that if n plus 1, that player, n plus 1th player, has defeated p2 or not. Okay, so if it has defeated p2, okay, then I'll just bring it and put it here between p1 and p2. Because why? First I asked p1 that I asked this n plus 1th player that have you defeated p1? If yes, then I put it in the front, because then an plus 1 has defeated p1. Okay. Otherwise, if this n plus 1 plus says that no, p1 has defeated me, then what I'll do is, okay, it doesn't mean that if p1 has defeated an plus 1, I can put it in I can put an plus 1 after p1. Why? Because you see, if I put an plus 1 here, if p1 has defeated an plus 1, then it might not be like an plus 1 has defeated p2 also. Because if I place p1, an plus 1, then p2, so this has to mean that p1 has defeated an plus 1, an plus 1 has defeated p2. So these two conditions should meet. So what we can do is, we can go step by step and ask that an plus 1, have you defeated p1? Okay, if yes, then sit here. If no, then go and ask, we will ask the second player, okay, here, that have an plus 1 defeated p2 or not. If yes, if an plus 1 has defeated p2, then we will bring and let an plus 1 sit here, because both the conditions are being fulfilled. Because first we went to p1 and I asked that have you defeated p1. Okay, if it would have said yes, then I would have put him here. But that player said no. That's why I went to p2 and asked that whether you have defeated p2 or not. Okay, and if the answer is yes, so then I put it in between p1 and p2, because then I know that p1 has defeated an plus 1, because that's why an plus 1 is not sitting here, and an plus 1 has defeated p2. And now let's generalize this. Okay, so suppose you have this thing. So not only for p1, p2, now we will generalize this for arbitrary. So suppose let's expand this further, that is p1, p2, p3, pi, pi plus 1, and till pn. Okay. Now the question is that if for any I, okay, we are going in this manner, and for the first time, if an plus 1 says that yes, I have defeated this ith player, then what we will do is, we will let that sit before that ith player. Okay, so if it sits before that ith player, so let's see. So suppose here I have pi minus 1 and here I have pi. Okay, now I went to p1, okay, and asked an plus 1, have you defeated p1? Okay, if it said yes, I'll put it here. If no, then I'll go to p2 and I'll ask an plus 1, have you defeated p2? If yes, then I'll put it here, right? Then the condition is that p1 is defeating an plus 1 and an plus 1 is defeating p2. Okay, and so on. I'll go and ask and keep on asking till the answer is yes for the first time. If the answer for this n plus 1th player is no, okay, no means I haven't defeated this ith player. Okay, so if an plus 1 says that no, I haven't defeated p1, no, I haven't defeated p2, okay, I haven't defeated p3, I haven't defeated pi plus I minus 1, but yes, for the first time it says that yes, I have defeated pi. Okay, I have defeated pi for the first time. Okay, we are going to every such player and asking that n plus 1th player, and for the first time, if it says that yes, I have defeated this ith player, then we put it just in front of that ith player, because this an plus 1 said no to pi minus 1, that no, I haven't defeated pi minus 1. So that means pi minus 1 has defeated an plus 1. And so this relation fulfills, that is p1 has defeated p2, p2 has defeated p3, till pi minus 1 has defeated an plus 1, and an plus 1 has defeated pi, and so on till pn. Okay, and now you can just relabel the thing so that it looks like p1, p2, p3 till pn plus 1. So what are we going to do is, this is p1, this is p2, this is p3. So this is just relabeling, okay, till pi minus 1, and then we will rename an plus 1 as pi, and p from this thing, that is from pi to pn, their index will we will add 1 to their index. Okay, so that means pi will be now renamed as pi plus 1, and so on till pn will be renamed as pn plus 1. And now we have basically arranged those n plus 1 players where this relation is holding, and thus by our induction hypothesis we have proved the statement. Thank you for watching. See you next time.